In this video, I will show that the series with the expression n times 3 to the n over n plus 4 factorial, that it converges by the ratio test, and that it converges to negative 1 over 81 times e to the third plus 53 over 162. Let a sub n be the expression n times 3 to the n over n plus 4 factorial. So a sub n plus 1 will be n plus 1 times 3 to the n plus 1 over n plus 5 factorial. And then the ratio a sub n plus 1 over n a sub n will be this expression over this expression. And then the n plus 1 times 3 to the n plus 1, we can write it as n plus 1 times 3 to the n times 3 to the first. And the n plus 5 factorial, we can write it as n plus 5 times n plus 4 factorial. And then notice that the factor n plus 4 factorial here and the factor n plus 4 factorial here, they will cancel each other out. The 3 to the n and the 3 to the n, they will cancel each other out. And so what's left up here is just 3 times n plus 1, and then we have the n plus 5 times n. So we end up with 3n plus 3 over n squared plus 5n. So the limit of a sub n plus 1 over a sub n as n approaches infinity. It would be the limit of 3n plus 3 over n squared plus 5n. And then divide each term by n squared. 3n dividing by n squared is 3 over n. And then 3 over n squared. N squared dividing by n squared is 1. 5n dividing by n squared is 5 over n. And then as n approaches infinity, we get each term of here will approach 0, and then 5 over n also approaches 0. And so for the whole thing we get 0. And therefore the limit of the ratio a sub n plus 1 and a sub n as n approaches infinity is equal to 0, which is less than 1. And therefore the series with the expression n times 3 to the n over n plus 4 factorial converges by the ratio test. And now let's show that this series here converges to negative 1 over 81 e to the third plus 53 over 162. So for the expression n times 3 to the n over n plus 4 factorial, the n here, we can rewrite it as n plus 4 minus 4. And this is the same as n plus 4 times 3 to the n, and then minus 4 times 3 to the n. And then n plus 4 factorial is n plus 4 times n plus 3 factorial. And the factors n plus 4 and n plus 4 here will cancel each other out. And so what's left is just 3 to the n over 3 over n plus 3 factorial. So this is our original series. And now we can rewrite it as the sum of the summation with 3 to the n over n plus 3 factorial minus the summation with the expression 4 times 3 to the n over n plus 4 factorial. And then here we can move this 4 and move in and place it in front of the summation. And so what we need to do next is find the value for this summation and then find the value for this summation. So let's find the value for this one first. And so now let's multiply this summation right here by 3 to the third. And so we get 3 to the third times 3 to the n, which is 3 to the n plus 3. When n is 1, we get 3 to the fourth over 4 factorial. And then plus, when n is 2, we get 3 to the fifth over 5 factorial, and so on. And so for this sum right here, we can write it as the summation with the expression 3 to the n over n factorial, with n starting at 4. Recall that the power series representation for e to the x is 1 plus x squared over 2 factorial, and so on. And now let's move these 4 terms right here to the left side, and then let x be 3. We get e to the third minus 1 minus 3 to the second over 2 factorial minus 3 to the third over 3 factorial, and which is equal to the summation with 3 to the n over n factorial, n starting at 4. And therefore this expression right here, 3 to the third times this summation, is equal to this. And that's what we have right here. And then now multiply both sides by 1 over 27 to get rid of this 3 to the third. So we end up with the summation with the expression 3 to the n over n plus 3 factorial is equal to 1 over 27 times all of this. And then simplify, we get 1 over 27 e to the third minus 13 over 27. And so we have just found the value of this summation right here. And then next we need to find the value for this summation. And so for this summation right here with 3 to the n over n plus 4 factorial, I'm going to multiply it by 3 to the fourth. And then we get 3 to the fourth times 3 to the n, which is 3 to the n plus 4. And then this is when n is 1, we get 3 to the fifth over 5 factorial, and then plus 3 to the sixth over 6 factorial, and so on. This is the same thing as the summation with 3 to the n over n factorial, and n starting at 5. Once again, e to the x is 1 plus x squared over 2 to the over 2 factorial, and so on. Move these terms right here to the left side, and we get the summation with x to the expression x to the n over n factorial, and n starting at 5. And now let x be 3, then we get e to the third minus 1 minus 3 to the second over 2 factorial minus 3 to the third over 3 factorial, and minus 3 to the fourth over 4 factorial. 3 to the fourth times the summation with 3 to the n over n plus 4 factorial is equal to this. And now multiply both sides by 1 over e to the fourth, and we'll get the summation with 3 to the n over n plus 4 factorial is equal to 1 over 81 times e to the third, and minus 131 over 648. This is our original series right here. And then we rewrote it as the sum of two summations right here. And then earlier we found that the value for this summation is 1 over 27 e to the third minus 13 over 27. And then we just found that the value for this summation right here is this. And then simplify everything. We'll end up with negative 1 over 81e to the third plus 53 over 162, which is approximately 0.07919. And that's the end of the video.